Hey guys, welcome back to learnix. In this video, we're going to be covering the laws of indices. This is one of the topics that comes up regularly in almost every single IGCSE paper, so you need to be solid on this. Let's get into it. So, power, roots, and indices part 2. This is a continuation of part 1, which I covered in the previous video. It was just like the basics, of powers, roots, squares, square roots, cube roots, and whatnot. Right? Okay. Starting with the simple question, what is an index, right? So let's understand the basics first. So let's say we have 2 to the power of 5, right? 2 would be our base and 5 would be our index or power or exponent, right? So basically what this shows is we have 2, which is our base, multiplied by itself 5 times, which is our index. So 2 times 2 times 2 times 2 times 2. That's it. Okay, so imagine now we have 12 to the power of 4, right? Same thing, this is our base, this is our index, right? We basically have 12 multiplying by itself 4 times. The power or the exponent basically tells us how many times the base multiplies by itself. Okay, so that's simple. Moving on to multiplying indices. Okay, this is going to be law 1, right? So law 1 states that when you multiply two powers with the same base, you add the indices. So let's say you have am, I'm going to use variables for this, multiplied by an, right? You probably have seen this, right? This will equal to am plus n, right? Notice here that the base in both of them is the same. The only thing different is the power. So when we have two numbers that have the same base but different powers and they multiply with each other, we'll write the base, and on top as the exponent we write both of the powers plus sum together, right? So that's just going to be a raised to power m plus n. All right. Okay, now let me give you an example. Let's say we have 2 to the power of 3 multiplied by 2 to the power of 4, right? That's simple. So basically same base, we're gonna write this, do the same thing, right? It's gonna be the base 3 plus 4. 3 plus 4 is 7, right? And then if you do 2 to the power of 7 in your calculator, we get 128. All right, now let's try this with a variable that we would use in our exams. Let's do x to the power of 5 multiplied by x to the power of 3. We would get, come on, take a guess, x to the power of 8, right? Okay, so the rule for this is that the base must be the same. The base cannot be different, right? The powers can be different and whatever else, but the base should be the same. You cannot do this with different bases. So let's say you have x to the power of 2 multiplied by y to the power of 2, right? Do not do the mistake of writing xy to the power of 4. That's completely wrong, and I've seen people do that. Okay, moving on to law number 2, right? When you divide two powers with the same base, you subtract the indices. You subtract the indices. When you divide two powers with the same base, you subtract the indices. So let's say you have a to the power of m divided by a to the power of n, right? You would get a to the power of m minus n. Another way of writing this would be a to the power of m over a to the power of n equals to a to the power of m minus n, right? Now again we're going to go with some real life examples, such as 2 to the power of let's say 6 minus 2 to the power of 2, right? This is going to equal to 2, same base. What's 6 minus 2? That's 4, right? So what's 2 to the power of 4? 2 to the power of 4 is 16, right? Now let's say in terms of x, we'll have x to the power of 7 over x to the power of, let's do 3. we're gonna have x to the power of 4. Same thing over here, the bases must be the same, right? As you see here, bases are the same for every single one of them. Powers may be different. Now, moving on to law number 3, the law of power of a power, right? So when you raise a power to another power, you multiply the indices, right? So let's say you have a to the power of m raised to power n, right? All of this is being raised to the power of n. So in this case, a to the power of m would be our base and n would be our power or exponent or index, right? So what we would do in this case is take our base and multiply the two powers. So it would be m multiplied by n, a to the power of mn, right? Now let's do this with 2, right? 2 to the power of 3 raised to the power of 4. We would get 2 to the power of 4 times 3, which is 12, right? Let's do this in terms of x, x to the power of 2 raised to power 5. You would get x raised to power 10, right? That's super simple. Okay. Moving on to zeros and negative indices, right? This is like, two special cases that you need to know, right? So let's say you have a to the power of 0, right? A to the power of 0 would equal to 1, right? Anything to the power of 0 is going to be 1. Let's say you have a million, right? To the power of 0 is going to be 1, right? Any number raised to the power of 0 is 1. Okay, so 2 to the power of 0 is 1, x to the power of 0 is 1, right? You get it, right? Now moving on to negative indices, right? Let's say you have a to the power of negative n. This will equal to the reciprocal of this. It's going to be 1 over a to the power of n, right? Let's say you have 2 to the power of negative 3, right? It's going to be 1 over 2 to the power of 3, right? Let's say you have x to the power of negative 1. It would be 1 over x, right? You would say, why not the power of 1? That's because every number is to the power of 1. So you don't need to write to the power of 1 over here, right? Okay, so basically a negative index just means that you flip it. You put it on the bottom of the fraction, right? And then you remove the minus sign, right? So let's say you're trying to simplify like 2 over 3 root x, right? Let's say you're trying to do integration or differentiation. That's actually AS level, but next year or differentiation this year, right? You need to know how to simplify this. That would be 2 over 3 uh, root x. We have done this previously. X would have the power of a half, right? Root means power of half. A cube root would be x to the power of 1 over 3, right? So basically this would turn into x to the power of 1 over 2, right? So what we can do over here is basically give x a negative power. So it's 1 over 2 over here. We can make that negative. What that will do is it will shift this x to the top, right? So that would look something like this: 2 over 3 x to the power of negative 1 over 2, right? Now you have it in the normal form of your coefficient and your variable, right? You have it in terms of x. So now this is something that you can go ahead and differentiate, right? Okay. Now moving on to uh, algebraic index expressions. Okay, let's try to implement this in algebra, right? We've already done the core concept. We're just trying to implement this into uh, examples that we are more likely to use in daily life, right? So let's say we have 5x to the power of 3 whole squared, right? So I want you to think about this, right? We have square over here. What's the square of 5? That's going to be 25, right? And now what's the square of x to the power of 3, right? We did this. 3 times 2, 6, right? Your answer is 25x to the power of 6. Now, let's say you have uh, 12a to the power of 5 over 3a negative 2, right? So you have 12 over 3, which simplifies to 4, right? And don't be confused with the negative sign or anything, right? Just remember, it's going to be 5 minus minus 2, right? So we just write the base there, 5 minus minus 2, right? Because minus 2 is what we have down here, right? So what's 5 minus minus 2? That is going to be 7, right? Minus minus plus, so 4a 7. All right. Now let's move on to a more complicated one. Okay, let's say we have 6x to the power of 7, y to the power of 4, multiplied by 5x negative 5y, right? Now we need to simplify this. All right. Now what's 6 multiplied by 5, right? What I would suggest you in these situations is always deal with the numbers first and then deal with each letter separately, right? Take it one step at a time, right? Numbers first, then letters. So what's 6 times 5, right? That's 30, right? That's simple. Now what's, remember multiplying, yeah? So what we're going to do is we're going to add them, right? So what's uh, the base is going to be x, so it's going to be 7 plus negative 5, right? So it's going to be 7 minus 5, right? Let me write this down for you. 7 plus we have negative 5, right? Now we have y. We're at the base there. We're multiplying, so we're going to add, right? The power on this is 1, right? So it's going to be 4 plus 1. 4 plus 1 is 5, right? Let's simplify this. 30x. 7 plus minus 5 is squared, right? Then y to the power of 5. That is it, right? All of this converted into this, right? Okay, now let's move on to an exam question, right? There aren't many exam questions about this. I mean, there are, but they're actually integrated into different exam questions and different concepts, right? So I have taken this from a question. It's the B part of a question, but it's unrelated to the A part, right? So in a book, the distance between two planets, let's say this is planet A and this is planet B, is given as 4.07 multiplied by 10 to the power of 12 kilometers, right? 4.07 multiplied by 10 to the power of 12 kilometers, right? The speed of light is 1.1 multiplied by 10 to the power of 9 kilometers per hour. Calculate the time taken, okay, for light to travel from one of these planets to the other. We know that the formula for speed equals to distance over time, right? How would we rearrange that for time? Take time to that side and speed down there, right? We would get time equals to distance over speed, right? So time would equal to the distance, which we have as 4.07 multiplied by 10 to the power of 12 over our speed, which would be 1.1 times 10 to the power of 9, right? Now what you would do is put this into the calculator and solve this, right? But for the example's sake, we'll just do this separately, right? So what's 407? We'll just write 407 over 1.1, right? There you go. You can do that on your calculator as well, and you will get 3.7, right? Okay, let's substitute this as 3.7. Okay, so you get 3.7, right? So that's this done, right? You get 3.7. Now you have 10 to the power of 12 over 10 to the power of 9, right? Same thing. You have two uh, you have two indices multiplying. You have two indices dividing with the same base. So we're going to write the base down. What's 12 minus 9? 12 minus 9 is 3, right? So you're going to write 3. There you go. That's your answer. This is in seconds. Then of course you need to convert into days and hours by converting into minutes and hours and days, right? But that's simple enough, and I hope you'll understand how to do that, right? Alright guys, that's all it is for this video. These rules constantly come up, so make sure you're comfortable with all the three laws plus zero and negative indices. Next video is fractional indices. That's extended only, so see you there.